Continuing on in Unit 4, we're going to talk about the kinetic theory of gases, which is a group of assumptions explaining gas behavior. Okay, the first assumption is that gases are made of small particles moving randomly with no attractive forces between them. So, a gas has small particles moving randomly with no attractive forces between them. Okay, the second assumption of the kinetic theory of gases is that particles are far apart. The third assumption of the kinetic theory of gases is that particles move faster at higher temperatures. And lastly, the fourth assumption is that collisions are elastic. So I'm talking about collisions between gas particles are elastic, and what that means is that the kinetic energy is conserved, so it's transferred onto another gas particle. So Ke stands for kinetic energy. Kinetic energy is conserved. Okay. So this next question, we actually deal a lot with gases in our everyday lives. We've definitely come across them. So if you think about your tires, they are filled with air, which is a gas. Would you expect a change in tire pressure from summer to winter? And the answer is yes. So as temperature decreases, the particle movement decreases. So from summer to winter. So temp decreases, particle movement decreases, and thereby pressure decreases. So if you have that tire pressure management system on your car, we have it on both of our cars actually. And it's interesting, as soon as it starts to get kind of chilly, both of our cars will say TPMS alert, TPMS alert. And so the tire pressure is too low, so then we just need to put more air in. So you don't notice it so much from winter to summer, because I guess they're a little overinflated. But you know, when you get a new car, or any car, they say check your tire pressure often, and it is a good thing. It's better to do that than to not check it. So, gases can be described by four properties. The first property is pressure, which we abbreviate with a capital P, pressure. The second one is volume. We abbreviate with a capital V, volume. The third one is temperature. Sorry, the speaker is not cooperating with me. So temperature, capital T. And then lastly, we have N, lowercase n, which stands for molar amount. All right. All right, so one of the things that we're required to know for this unit is to describe the units of measurement used for pressure and change from one unit to another. So we're talking about pressure with gases. Remember, that was one of the properties that we just went over that could describe a gas. So pressure is defined as the force per unit area. The units of pressure are atmospheres, or millimeters of mercury, or torricelli. So atmospheres are abbreviated ATM. So at sea level, atmospheric pressure equals 1 ATM. Millimeter of mercury, or torricelli, often are used for blood pressure readings. Okay, so these are conversion factors that you should be familiar with. 1 atmosphere is equal to 760 millimeters of mercury. 1 torr is equal to 1 millimeter of mercury. So it's almost like they're the same unit, 1 to 1. So let's go through some conversions. The pressure on a jet airliner is 22 centimeters mercury. How many atmospheres is this? How many torr is this? Okay, so we're going to set this up as a conversion problem where you put 22 centimeters of mercury over 1. We're trying to convert this to centimeters of mercury to millimeters of mercury, and then on to atmospheres. Okay, so in order for this conversion to work out, we need to divide by centimeters of mercury and multiply by millimeters of mercury. So you can use the prefix ladder to generate these conversions. You remember this basic unit, deci, centi, milli, micro, nano, kilo, mega. So this is 6, 3, 1, 2, 3, 6, 9. We are converting from centi to milli. So 1 centimeter of mercury, so if I start at centimeter to get to millimeter, it's going to be 1 to the right. So I'm going to move it 1 to the right. So 1 centimeter of mercury is 10 millimeters of mercury. So I'm going to calculate this because we were asked for millimeters of mercury, which is the same as torr, right? So this is torr, millimeters of mercury. So 22 times 10 gives you 220 millimeters of mercury. And then, so we've answered this part. Now we need to convert to atmospheres. So now that I have it in millimeters of mercury, I can convert to atmospheres. So I'll put that over 1. 760 millimeters of mercury, 1 ATM. Divide that out. So you end up with 0.289 ATM. We'll round to 2, so we call that 0.29 atmospheres. Okay. We're going to work on some more conversion problems involving pressures. So keep those conversion factors handy. It definitely is helpful to know them, have them memorized. So let's look at this next one. At the top of Mount Whitney, atmospheric pressure is 0.6 atm. What is the pressure in millimeters of mercury and also in torr? So this question is a great example of what happens as you go higher in altitude. Perhaps you guys have been to Colorado, and maybe you've been up in the mountains in Colorado and you're trying to do something and you get so out of breath. The reason you get out of breath is because atmospheric pressure is lower on the mountains. So there's not as much oxygen in the air for your body. So you get out of breath easier, you get lightheaded, you might even get altitude sickness. So it's really important to hydrate. It's really important to kind of take it easy the first few days, you know. And you hear of some Olympic athletes training at high altitudes because their body gets accustomed to lower oxygen levels, and so they're in better physical shape for their competitions. Okay, so Mount Whitney, the atmospheric pressure is 0.6 atmospheres, so that is lower than sea level. Sea level is 1 atmosphere. What's the pressure in millimeters of mercury? What's the pressure in torr? So these are both the same. So we just have to do one conversion. So I'm going to put 0.60 atm over 1. And 1 and atm always go together. 760 millimeters of mercury or torr. So I'm going to multiply 0.6 times 760 millimeters of mercury, and I should end up with, 456 millimeters of mercury. Or torr. And I'll take that to 2 digits. So I end up with 460 millimeters of mercury or torr. And this last one, your blood pressure is measured in torr. So if you ever go into the doctor's office, and maybe if it's an older doctor's office and they still have this sphygmomanometer on the wall, that's the blood pressure cuff. If you look at it, you might notice a few things. And of course, I always look at these things when I go to the doctor. The really old ones that are mounted on the wall, most often the substance inside the sphygmomanometer, I have a hard time with that word, is mercury. So, it's kind of like mercury thermometers. There aren't very many of them around. So if this piece of equipment gets broken, it's kind of a big deal. You have to do a special cleanup. You can't just play with mercury. The other thing you'll notice is that the units on this, the readout on this, are usually torr. So it's written in cursive often. So if you have a chance to look at that and observe it, take a look. Okay, so your systolic and diastolic blood pressures, that you're given too. So we're given these blood pressures, and I want you to convert them to atmospheres. I want you to convert them separately. So I'm going to say 115 torr and 75 torr. So convert those separately. So remember that 760 torr is 1 atmosphere. And 1 atmosphere is 760 torr. So you end up with 0.15 atm and 0.099 atm here. So your blood pressure, when it's written in atmospheres, is like, wow, my blood pressure is really low. So I always joke around with students, like, if your blood pressure is ever high, just ask them to convert it to atmospheres. So that finishes our unit on gas and pressures and converting units of pressures. Be sure that you do the homework problems corresponding to these this unit so that you get practice. And the next portion of this lecture will cover solutions.